Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together.
When it comes to graphs, if you're really good at graphing or if you have a graphing technology device available to you, they can really help our algebra. However, we have to be able to have an understanding of what a good viewing window is. So things that we can get should we have a quality viewing window is we can visually see the domain and the range, as well as compare or solve when things are equal, greater than, or even less than. We can actually visualize increasing versus decreasing. Remember, increasing would mean be going uphill, whereas decreasing would be going downhill. And then we can also see whether things have whether there's a local max or a local min. Now, what do I mean by local maximum or minimum? If you were to look at your window right now, I'm sure there's the highest point that you could see something besides sky, like the highest tree. Now, just because it's the tallest tree outside your window doesn't mean it's the tallest tree in the world. It's locally the tallest tree. So when we're looking here, this graph happens to have a local maximum and a local minimum. Whereas this graph has no maximum and it has what's known as a global minimum because it's the lowest point ever on the graph. Where this is just locally the lowest point, it still goes lower. And we can actually use technology to calculate those, and then if we have been taught how to do the algebra, we can use the algebra to support it. So keep that in mind. One of the things that we can always do to help us out is, let's say we have x to the third minus 2x squared plus 1. We can come in here. Okay, I'm seeing a high point and a low point. I went into my calculate menu, which is by right there, second trace. And if I put number 1, it comes up with this cursor. And if I type -1, it substitutes for me, which is great. What if I substitute 0? Okay, 0 looks to be like it's a high point. 1, 2. Okay, so somewhere between 1 and 2 is the low point. So what about 1.5? Doesn't look like it's quite the low point, right? 1.6. Whoops. 1.4. We could keep working. However, there is a way to make our calculator actually tell us that number right now. And in calculus, you'll learn how to do it for any value. But if you get stuck calculating a minimum, what we're going to do is we're going to go into this same menu, this blue calculate menu, and we're going to calculate minimum. Now the minimum is right where the cursor is. It's between the cursor here on the left. I hit enter, and arrow to the right, hit enter. It's between those two little vertical lines. When it says guess, I really don't care. And it's going to tell me now it's at basically 1.3 repeating is where this is. And so how low does it go? Well, that would be -1.86. When does it occur? When x is 1.3 repeating. So calculating those values can be very helpful. And again, I use calculus. So what about over here with this maximum? We can do it very simpler. So I'm going to blue button, trace button. And this time we're going to go maximum, so that would be number 4. Now I have to get to the left of my maximum. So now I'm left of my maximum. I don't care how far left you are, right? I went very far left. Now I have to get right. Now you don't want to go so far past it that you are higher than your maximum. That would be bad. You want to kind of keep it within reason. So don't make that too wide. The wider you are, the harder it is on your calculator. And then it'll tell you, oh, well, it says 2.57 times 10 to the negative 6th. That's pretty darn close to 0. So it looks like 0,1 is our maximum. So the calculator and the graph, assuming a good viewing window, is a great way to do it. If you understand the relationship between turning points and our degree is 3, which means the most number of turns we could see is 2. And I can clearly see my 2 turns, so I know I'm seeing everything in my picture. So that's very important. The other thing that it's great for is finding our domain and our range. Okay? And remember, our graph is as only good as our viewing window. So let's look at the graph 4 minus x squared. Okay? This is a root graph, so the domain is going to be limited because what's underneath has to stay positive. So 4 minus x squared has to stay positive. I'm not seeing much, and it looks like there's a gap. So let's actually I'm going to make my window. No, my window is pretty small as it is. Negative 3, 3, negative 1, 3. Now that I've zoomed in a little bit, it doesn't look like there's so much of a gap. So does it include this point? So I'm going to calculate a value. Did it include negative 2? Absolutely. Y exists there. Well, why is negative 2 the smallest thing? Well, negative 2 squared is 4. 4 minus 4 is 0. So anything past that is going to give us negative answers. So we can see here from our graph, our domain is from negative 2 to 2, but our range is only 0 to 2. Oh, it's a half circle. That's what this was. So for this, we wound up with a domain, negative 2 to 2, and a range, 0 to 2. Why was the range positives? Well, they only utilized the positive square root. Why was this negative 2 to 2? Well, we know 4 minus x squared had to be greater than or equal to 0. So 4 had to be bigger than or equal to x squared. So that means 2 had to be bigger than or equal to the absolute value of x. Okay, so you want to use this to make your life easier. Your teacher is going to make you show work, but who said you can't know the answer before you get started, right? That's the whole point of this whole using graphs thing, is to make sure we know the answer before we even get started. Okay, so 2x squared plus 3 equals 5x plus 6. There are 2 ways we can do this. I do not like option 1, but we will do option 1. First of all, I'm going to reset my window. My favorite window is left 10, right 10, numbered by ones. Left 10, right 10, or sorry, up 10, down 10, up 10, also numbered by ones. So I'm going to come into my y equals, and I'm going to put my first equation, everything to the left of the equal sign, as this, and everything to the right as my other. And I'm going to graph. They do look like they meet. Okay, so calculate this time, since they look like they meet, I'm going to use number 5, intersection. And I'm on my first curve is in blue, I'm highlighting the blue, I'm going to hit enter. My second curve is red, I'm highlighting the red, I'm going to hit enter. And my guess is about right here. And I get that they do meet at negative 1/2, 3.5. But they look like they're going to meet again. So if I go in my window, now I just got to go up higher, right? So I'll go up to 20. Graph. They do meet again. Okay, so calculate an intersection. Arrow over close to it. I'm on the blue, I'm on the red, I'm guessing. 3,21. Okay. But these were x, y ordered pairs. And if you'll notice, only x was mentioned. So my actual answer is x equals -1/2 or 3. Or if I'm writing it in set notation, -1/2, comma 3. It's just a list. There were two x's that make it true. I don't like doing it that way because it would have been really easy for us to miss the second answer. Instead, what I prefer to do is clear out that completely. I like to make it all equal 0. So I'm going to subtract 5x, and I'm going to subtract 6. Everything's on one side. It's a parabola. I should be seeing up to 2 answers. Oh, there they are. And now, I'm going to fix my window. I don't like going up that high. Now I can just calculate a 0, which is menu number 2. Get to the left, get to the right, hit enter. There's that -1/2, which is what we had, right? And then the other one we can see is at 3 as well. So I like making it equal 0, then graph, then calculate a 0. Now that I know my two answers, I can actually come back in and I can solve it algebraically because your teacher's probably going to want to see that. However, I'm going to cheat. I know that one of my answers is 3, so I know when I factor, I'm going to have x minus 3. The other one's -1/2, which will give us 2x plus 1. And now, excuse me, if I know my relationship between my zeros and my factors, my teacher's not going to know that I couldn't factor mentally because it's impossible to identify. So I can use my relationship between my factors and my graphs to kind of reverse engineer my work. Okay, what if they changed it though? What if they said 2x squared plus 3 is less than 5x plus 6? Okay, well, if you did it the first way, they want to know when is the smiley face below the line. I don't like doing it that way. Okay, I like going, hey, when is it less than 0? When is the parabola less than 0? Because now I have a flat spot to work with. And now I can say when x is between -1/2 and 3. So those endpoints are still going to come in there, but it's really going to help us out with seeing those that we're always comparing to 0 instead of comparing to something random. Okay. Now, I know I showed you a minute ago how to calculate a maximum and a minimum. Why would that be important? Well, okay. This is A, and this is B. Maybe, I don't care where 0 is. Maybe 0 is clear over here. It doesn't matter. So I think you would agree that the graph is going uphill, uphill, uphill to its maximum, wherever that happens to be. Then it's going downhill, 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 downhill to its minimum, wherever that happens to be, and then going uphill again. So based off our independent variable, based off of our x, our graph is increasing between -infinity and a, and then it's increasing again between b and infinity. So I just talked about this part and this part. And that's kind of like using the walls. I've talked about before in some of my videos, mostly my Algebra 2, about how domain and range could be ceiling, floor, or walls. So when we're talking increasing, decreasing, we're talking about like walls. So between -infinity and a wall at A, we're increasing. Between B and infinity, we're also increasing. However, in between these two walls, the wall of A and the wall of B, the graph is going downhill. So we're decreasing between A and B. I don't care how much, we're just going down. Do I care about how much the drop is at this point? No. I just want to know, hey, when you use these x values, know that as you move from left to right, your graph is going downhill. So increasing and decreasing refers to uphill, downhill. Okay, so make sure that you are able to do several key things on your calculator. And that would be able to, 1, change your viewing window. And I don't mean by using the zoom features, okay? Because sometimes it changes what you number by really weird. I mean, you should be able to manually change your viewing window. Okay, you should be able to calculate a value. A 0, a minimum, and a maximum. And you should also understand what you want to see in the window. If it's a parabola, you should be able to know what a parabola is. If it's cubic, you should know what a cubic function is. So just being able to do those things will also help you out. I will put the note that it is never a bad idea to understand how to calculate an intersection as well. But overall, getting an understanding of your graphing utility to help you out in the mathematics classroom is a really key feature to helping put you just more confident on your exams. It will help you get your answers so that you can support it with work.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? And drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.